Send it to Riley. Okay, once you do your prime factor trees to get the prime factorizations for each radican, we'll write that in place of the number. So for an example, square root of 9 is also the square root of 3 squared. And the rule is when the index and the exponent match, the answer is the base of the radican. So another way to write 256, you know 256 is the perfect square and the square root of that is 16. But I want you to think about another way to write 256 is 16 squared. When the index, square root, and the exponent match, the answer is the base of the radican, which is 16. Look at a couple more that are perfect squares. The square root of 324 is the same as the square root of 18 squared, which is 18. Does anybody remember the square root of 441? Another way to write 441 is 21 squared. So this is the key for all these little mini examples here. When the index, and when you don't see an index, that means it's a 2 for square root. When the index equals the exponent, so in all of these examples, the index was a 2 and the exponent was a 2. When they're equal, the answer is the base of the radican. And we're going to be using this for each part of the prime factorization shortly. But let's do a few other shorter examples to get you to notice that when the index and the exponent are the same, the answer is the radican. Here the exponent is 2, the index is 2, so the answer is 5. Here the exponent is 2, the index is 2, the answer is 31. And 11 squared, the square root of 11 squared is 11. However, we can also use this for parts of a prime factorization. So if the index and the exponent match, the answer is a 2. And times the index and this exponent match, so 3, 2 times 3 is 6. So that's why we have you writing the prime factorizations in the radican position. This is true for cube roots. The cube root of 7 cubed is a 7. The fourth root of 2 to the fourth is a 2. So as long as the index and the exponent matches, the answer is the base, no matter if it's square roots, cube roots, or fourth roots. In this case, the 2's match, so a 3 would come out from under the radical sign. The index and the exponent match, so another 3 comes out, and 3 times 3 is 9. Even if the numbers aren't prime, like 4 isn't prime, but you still have an index and an exponent matching. The square root of 3 squared is 3, and the square root of 4 squared is 4. 3 times 4 is 12. Now in the last example, you should know that if the index and the exponent doesn't match, your answer is simplified already. The square root of 17 is already simplified. If you pick up your calculator and type in the square root of 17, you will get some kind of estimated decimal answer, but radical 17 is your exact answer. So for most of this chapter, we will be dealing with exact answers, not rounded decimal answers. All right, turn over to the second page of your notes. Here are the steps. Do a factor tree, and you can do that on the side. Write the prime factorization of the radicand under the radical sign. We're going to be rewriting the radical so that our exponents are all 2's. And then we're going to simplify the radical and simplify completely. So here's what that looks like. Go ahead and draw factor trees for 12 and 98. I'm going to do them over here in the margin for you. So replace the radicand 12 with the prime factorization, 2 squared times 3. So 2 has an exponent of 2, and 3 has an exponent of 1. Only one of these matches the index of 2. So the square root of 2 squared, or the square root of 4, comes out of the radical as a 2, but 3 to the power of 1 stays under. So this is your final answer. Square root of 12 simplifies to radical 3. We'll check your work. I need you guys to pick up your calculators and type in the square root of 12. I got my calculator. To type in square root of 12, you do second x squared button and the radical sign will come up, and type 12. And it's going to give you a decimal answer, 3.464 and so on. I'm going to round it right there. A 1 rounds, keeps the 4 at 4. Now see if you got it right. Go down here and type in your calculator 2 second x squared 3 and hit enter and see that you got the same answer. So you know that these are equal. But your decimal answers are rounded, they are not exact. This is the exact answer. We're going for exact. Go ahead and work on a factor tree for 98. Remember that 8 is even, so 98 will divide by 2. Two is prime, circle it. 49 is not. (49) is 7 times 7. So what we're going to do in the place of the radicand, we're going to write the prime factorization of 98, which is 2 times 7 squared. 2 has an exponent of 1. 7 squared has an exponent of 2. So the square root of 2 stays underneath because the exponent and the index do not match. And the square root of 49 is 7. I'll give you a moment to check your answers. What is the square root of 98 as a rounded answer? And what is a square root of 7 radical 2 as a rounded answer? And that's going to round to 9.900. Three is a little bit different because we have an exponent that is higher than 2. Go ahead and do your factor tree for 72 and 70. So you should be drawing out your factor tree on that margin. 9 times 8. 3, 8 is 2 cubed. I probably shouldn't make that leap. 8 is 2 times 4. And 4 is 2 squared. 1, 2, 3 2's. So another way to write 72 is 2 to the power of 3 and times 3 squared. Now, you know, when the index and the exponent match, the answer is the base of the radicand. But once you have an exponent that's bigger than 2, instead of writing 2 cubed, I want you to rewrite the prime factorization as 2 to the power of 1 times 2 to the power of 2 times 3 to the power of 2. 2 and 1 combine and make the 3. So pretty much I split this 3 up into a 1 and a 2. I did that so anything with the exponent of 2 can come out. The square root of 4 is 2. The square root of 9 is 3. But this 2 to the power of 1 stays under the radical. So the square root of 72 is 6 times radical 2. Now do the check. Pick up your calculators. Do second x squared 72. That gives me 8.485. And then type in 6 second x squared 2. I got 8.845. And they check. Number 4 is an interesting example because once you do your factor tree for 70, is 7 times 10. 7 is prime and 10 is 2 times 5. You'll notice that you have all prime numbers with exponents of 1. In that case, none of these exponents can be made to match a 2. So in that case, the square root of 70 is already simplified. And if you get any like this on your homework, you must write the words already simplified so that I understand, you know, that the indexes and the exponents are not matching. Radical 70 is in lowest terms. Okay, so we have finished the notes for Unit 4, Part 4. You can go ahead and put your notes away. We are in Part 4. Now we're not in school, so I can't give you the handout, but you could find the handout. Unit 4, Part 4 homework is right here. And you could open this up on Schoology and print it off, or you can complete the problems online paper, just so you know what it looks like. Unit 4, Part 4 starts with radical 225. Now, some of these are perfect squares. You already know that the square root of 225 is 15. But if you want to show the work with the prime factorizations, that's how I solved it. Once you finish part 4, you need to hand it in before class starts tomorrow. And let me add that to the list. So here's the sheet you need. Right after it, I'm going to add an assignment. All right, thanks for your time there. So this is the handout that you need. When you're done, either doing it on line paper or printing it out, you hand in a photocopy of it here on Schoology. I'm going to stop the recording and stop the share.